So for number 1 on the homework today, you should have ended up with C as your answer. And remember, the equation for that one is your hydrocarbon, in this case C4H8 plus oxygen. It's going to give you CO2 and H2O. So you can run through and balance that. C is the answer for that one. Then down here, remember that vapor pressure, weaker vapor pressure or higher vapor pressure is going to indicate that we have weaker intermolecular forces. So in this case, the higher vapor pressure would be the correct answer for this one. All right.
Hey, look, you guys had a great idea for a roll camera that you should do for the final test of the year. Make all the answers C or D or just one letter, all the way through the entire test. I think that would be hilarious.
Only problem would be if one student knows all the answers and see to tell the rest of the class.
Yeah, but more than likely they're going to be second guessing themselves on why you know them C.
All right. You got time on this one? Good. Ready? Okay. So this one, we're going to predict the relative strengths of these compared to the water molecules. Remember that we've got why am I blanking on this one?
There's a chart up above this goal.
That's why I'm blanking on it. That's why I'm having trouble. Okay, there we go. Okay, there. That's what I needed. I needed this ionic radius in front of me to make sense of this. Okay, so zinc's ionic radius is 74, and we're increasing as we go down. So the smaller the ionic radius, the closer the pull of the nucleus is going to be. And so this is the order that this should appear in. And smaller ions have a stronger Coulombic charge to the water. Okay, does that make sense?
C.
C. Well, BA would not be, yeah, so it has to do with, they're not talking about IMFs here. They're talking about the strength of attraction between them. Yeah, so this would, yeah, so that's, yeah. All right, zinc. So see if you can figure out what this one would be. You guys ready? Okay. So zinc is used to reduce other compounds. If a chemist needs a substance that's more effective, which one of the following would be the best choice? Okay. So if we have these two here, they already have a plus ion. Okay. And so hydrogen can't lose another ion in order to reduce something. Okay, it can't do that. It doesn't have any electrons to lose. It's already lost everything that it can possibly lose. So that guy is out. Okay, this guy, if he tried to lose another electron, okay, because remember, if we're trying to reduce something, so that means that if it's reduced, this thing has to be oxidized, which means that this thing has to lose another electron. If he's losing another electron, he already has the electron configuration of a noble gas. So for him to lose an electron as a noble gas configuration, like as a noble gas, that's probably not going to happen. This guy, he's already gained an electron. So he's already stable. He already has an electron configuration of a noble gas. So he's not going to, that leaves us with sodium. And if you think about sodium losing one electron, that's pretty easy for it to do, because then it's going to have a noble gas configuration of it's going to have a configuration of a noble gas. So, sodium is the correct answer for that one. All right, try number 5. Oh, this is a fun one. I always get people on this one. Good. Okay. What kind of bond or what kind of experience would be happening here? What pole is this? Positive or negative?
Would that be a repulsion?
Yes, this is a repulsion. What about this guy? Repulsion, because these are both positive ends. So these are going to be repulsed. Okay. What kind of bond is this? Do you see the difference between this bond and this bond in the picture? What's the difference between them? One's a solid line and one's dotted. This one's much stronger. This is intramolecular. What do we call that one between two nonmetals? What kind of bond is that? Covalent bond. Okay, so that's a covalent bond. Here is your hydrogen bond. Remember, hydrogen bond occurs between a hydrogen that's attached to an oxygen, fluorine, or nitrogen. That oxygen, fluorine, or nitrogen needs to have at least one lone pair of electrons. This oxygen would have 2, and then you get hydrogen bonding established. Okay? All right, do the next one. So for that one, the answer would have been D. You guys ready? No? So decreasing the volume of one of the components. So we're reducing the amount of material that's going in. Would that increase the rate of reaction? Does that make any sense? No. Decreasing the concentration, same deal, same idea. Decreasing the concentration, not going to happen. Decreasing the temperature, making it colder. Does that usually help the rate of reaction? No. So the only thing that makes sense here is decreasing the particle size. If we're decreasing the particle size, we're increasing the surface area. And remember, increasing surface area will increase the rate of reaction. Remember that? Okay. All right, let's look at number 7. Tell me when you guys are ready. Give me a thumbs up when you're ready. Cadence is already dozing off over there. You have 2 moles here. Whoops. Yeah, you're nice. Ready? Okay. Let me make sure my camera is still working here. Yep, it looks like it is. Okay. So what does this K value indicate to us? This is a really large K value. That indicates that our products are going to be favored at equilibrium. Okay. So chances are we're going to have a lot more of this stuff than we will have this stuff. This stuff is going to become this. So more HI will form would be our correct answer. Now, does the total pressure decrease? Well, we've got 4 moles here. We're going to 2 moles here. We're going to 2 moles. The pressure should stay about the same. More H2 and I will form. It's not going to go this direction because our K value, and then no net reaction. There will be a net reaction. So B is the correct answer for this one. See what you can do for number 8. Good? All right. So here we've got our distribution. They're going to show that to us again. Now, if the temperature goes up, that would indicate a graph that would look similar to this. We would have more things at this end. But lowering the temperature, no. Here, this situation would show us, they've actually taken some molecules out because the number of molecules has gone down here compared to what it was. And they told us, they didn't tell us that it was sealed, but we're going to assume it is. Here, again, the same idea as it was up here. And then here would be the only logical answer, because here your temperature would have decreased. Does that make sense? So D is your answer? Yep, it's going to go slower, so your speed is going to be less. There'll be the same number of molecules, but they're going to be at a slower speed. So they're going to be tucked over on this side. Does that make sense? Well, this, wait a second. Shows a speed distribution at the lower temperature as a dashed line. So the lower temperature is the dashed line.
You could almost think of it as like the dashed line being ice, and then as it melts, there's more water that kind of spreads out further. That's kind of how I.
Well, and the speed is going to increase of those molecules. But they're lowering the temperature, so it's going to be mushed over here because their speed's going to be slower. All right, see what you can do for number 9. So your water heated up, right? Your metal cooled down. So everything cooled down to 30, or heated up or cooled down to 35 degrees Celsius. So the final temperature, this last one here, the final temperature is less than the average starting temperature of the metal and the water. Well, that's not true because the water's temperature actually went up. So I would get rid of D right away. Here, the metal's temperature did change. Did it change more? And it says that it changed more than the water did. So all of these are the same up to that point. Therefore, the metal lost more thermal energy than the water gained. Well, if the metal lost more than the water gained, where did the rest of the heat go? Because it just didn't go away. So that guy's out. But the metal lost the same amount of thermal energy as the water gained. I like that guy. The heat capacity of the metal must be greater than the heat capacity of the water. No, if that was the case, then the water's temperature would have risen higher than the metal had lost. So it has to be B. Good? All right, see what you can do for number 10. This is a doozy. You ready? Yeah? No? All right. So they have, these things are mixed together. The iodine and tellurium are mixed together. They have similar atomic masses. Sample was believed to be a mixture of these two. They ran it through the mass spec. All the following statements are true. Which one would be the best for concluding that this was pure TE? Well, Te forms ions with a -2 charge, where that isn't going to tell us, like the mass spec isn't going to do, this is talking about mass here. It's not talking about charges. Okay, so that's not going to help us at all. So we can get rid of that. Te is more abundant than I. Well, we can't tell that from this data. It's also not going to tell us that from, you know, to be able to say that this is a pure sample. All right. I has a higher first ionization energy. This is a mass spectrometer. It's not talking about charge. Get rid of that one. Make sure that this one sounds valid. I consists of one naturally occurring isotope with 74 neutrons. Well, if this guy has 74 neutrons on it, 74 plus iodine's number is 53, that makes that what? 127 for its mass. Well, lo and behold, we go up here. There's nothing in 127. So if that was the case and this was pure tellurium, that would make sense, wouldn't it? Is that what you guys had for your answer? Good. Why is this not erasing? It hates me. There we go. All right, see what you can do for the next one, number 11. Remember our Bronsted-Lowry conjugate bases? Are we taking hydrogen and taking away hydrogen? But it's only one hydrogen. All right, so if we look at these pairs here, if we look at these two here, how many hydrogens are getting subtracted here? 2. So that guy's out. How many hydrogens are getting subtracted here? 1. So he's a good contender. Are these even the same things that we're comparing back and forth? No. And then how many hydrogens are getting lost here? Good. All right, try number 12. Remember, I told you to remember this chart. I told you to memorize it. This is the type of question that you would want to have this chart memorized for. Okay? So this is talking about at low temperatures. It's not thermodynamically favored at low, so it's going to be thermodynamically favored at high. Okay? And remember, we're looking at zeros here, so greater than and greater than for our S and G, so that would make this B would be our answer. If you memorize this chart, this answer. This question should be very easy for you.
What year is that?
This was your 9-3 notes.
I remember seeing it somewhere.
So topic 9-3, I would memorize this chart. And I talked to you when we were doing this, I talked to you about how this looks like it's everything. Like when you look at those things, it's including everything. Everything's included. This one, everything's excluded. Okay? So it's not going to ever work. And this one, if you go that direction, if you think of that in your brain, like, oh, that's going to the high, high, high. And this would be going to the low, low, low. Does that make sense? So memorize this chart. All right, I think that was number 12 then. So then we're on to 13. Let's see if you can figure out 13. It takes up the whole stinking page here.
The AP test will these be smaller? So like it'll actually like have the setups?
Yeah, this is like a legit like AP test. Well, it's quite, it costs $100, you know, a lot of paper. Well, you get down here though, there's coming up like this is 3 questions here, or 2 questions here, and then like down here, look at how many they got crammed down there. So it just varies. Give me a thumbs up when you got this one done. Good? Okay. So this one, if we look at this one, first of all, these 2 you can automatically eliminate right away. Why? Right, they're not diatomic, okay? So these are gone. Like we don't even need to, you shouldn't even like giving them much time of day at all, okay? Down here, if you look at this, I've got 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 12. But over here, I've only got 1, 2, 3, 4, 5, 6 hydrogens. So what happened to those other hydrogens? Who knows? Okay. Over here, I've got 2, 4, 6. I've got 2, 4, 6. C is your answer for this one. Okay. 13. Was that 13? Okay. So we're on to 14 now. Good, good. Okay. So remember, when we are at S here, our HA and our A minus are going to equal each other. That's the half equivalence point. That means that we've used up half of this stuff, half of it's gone, and we formed an equal amount of this. Okay? At here, which they don't have denoted for this, and how did I know that that was half equivalence point? Because this is my equivalence point. It's at 40 mils. So my half equivalence point has to be 20 mils. Okay? So at this point, this guy equals this guy. Okay? At my equivalence point, I've used up all of this stuff, and I'm just at water and some of this stuff. All right, so that means that R here, I've got more of this than I have any of this other stuff, because this guy I don't have, once he hits this, he forms into that. So I don't have any of that guy present at all. Okay? So then now they're asking us about U here. So figure out what is at, I think that's what they're asking. Which of the following is the best, other than water, that are present at U in the titration? So U is here. And I need to get rid of some of this stuff on the screen. All right, so if I am at U, okay, what is going to be present according to this equation? Okay, and I'm also going to have this stuff because I don't have any of this to react with it. And I'm going to have sodium in there because that's part of this OH. So this one is out because it doesn't have any OH present in the diagram. Same deal here. And at that U, I wouldn't have any HA left at all. And again, I wouldn't have any HA left at all there either. Okay, so that makes B the correct answer for this one. All right, work on 16. Okay, which point is A minus closest to twice HA? A so HA equals 2A minus. What'd you get?
I said T because at S they're equal in amounts, but then once we get there's no HA.
Right. Yep. Does that make sense? Okay. So U, there's none of this would be left, so that would be out. And here they would be equal to each other, so it has to be T for your answer. All right. So where do I leave off here? I want you guys tonight. We got through 15 questions, I think. So I want you to go up 16. I want you to go up through let's go up through 40 tonight. Okay. So try to go through 40 tonight and see what you can do.
We need the multiple choice, right?
Mm-hmm.
It's in here.
Yeah. I need to stop this presentation here.
Oh, I forgot about those.